Now going back to a couple of problems that we skipped earlier, we determined that number 7 was exponential growth. Now on number 6, since this is less than 1, that's B, then that's an example of exponential decay. And then to identify the percent rate of change, here's what we want to do. The 0.95, that's basically the 1 minus R. So what you're actually subtracting from 1 to get the 0.95 is 0.05. So R would be 0.05 as a decimal, but I want to change that to a percent. So in order to change that to a percent, I would multiply by 100 or move the decimal 2 places to the right. So that's 5%. That's the percent rate of change. In this case, it's the percent decrease. So the rate of change, if it's exponential decay, would be a percent decrease. And then the rate of change as a percent for exponential growth would be a percent increase. So again, for number 6, it would be a 5% increase. And then number 8, this number right here, 3/4, that's definitely less than 1 and more than 0. So this is also an example of exponential decay. Here's what you might need to do. Change the 3/4 to a decimal. That's 0.75. Again, that's 1 minus R. So the percent rate of change, or in this case, the percent decrease, here's how we figure it out. I could take 1 minus the 0.75 to really get R, and then that's 0.25. So R is 0.25, but I want to change that to a percent because it asked you the percent rate of change. So that's 25%. It's a 25% rate of change, or even more specifically, a 25% decrease in this case. And then looking at problems 2 through 5 now, I want to determine whether the table represents exponential growth function and exponential decay function, or possibly neither, and then explain. So for it to be an exponential growth or decay function, there has to be a constant rate of change for x, but then there has to be a constant multiplier for y. If that constant multiplier is more than 1, then it's exponential growth. If it's less than 1 and greater than 0, then it's exponential decay. So on number 2, there's a constant rate of change for x for sure, 0, 1, 2, 3. X is increasing by 1. But then for y, the first thing that you should notice is it's an increase. It's not linear because you're not adding or subtracting the exact same number for y each time. 20 plus 10 is 30, but 30 plus 10 is not 45. So it's not linear. But to determine if it's exponential growth, it can't be exponential decay because y is increasing. So it's impossible for it to be exponential decay. If you're multiplying y by the exact same number every single time, that's more than 1, then it would be exponential growth. So if you can't figure out exactly what you need to multiply 20 by to get 30, but you multiply 30 by to get 45, then do the opposite. 30 divided by 20 is 1.5. That means 20 times 1.5 is 30. 45 divided by 30 is 1.5. So 30 times 1.5 is 45. And then 45 times 1.5 is 67.5. So there's a constant multiplier or a constant ratio that you're multiplying y by to get the next y. This is more than 1. 1.5 is definitely more than 1. So it's an example of exponential growth. And then maybe you could try problems 3 and 4, possibly 5 as well if we go over all of them before we go over them together. Maybe pause the video and see what you can do. So on number 3, x is increasing by 1 each time. And then what happens with y is you're multiplying by 0.25. If you thought dividing by 4, yes, that's correct. But you have to figure out the constant ratio is what, and that's what you multiply each by. So if you did 40 divided by 160, that's 0.25. 10 divided by 40 is 0.25. That's the constant ratio. It's less than 1 and more than 0. So this would be an example of exponential decay. And then on number 4, x is increasing by 1 each time. If you try to multiply 32 by some number to get 22, again, what you could do to figure out what you multiply 32 by to get 22, you could just divide 22 by 32 and then then that's 0.6875. So 32 times 0.6875 is 22. If you divide 12 by 22, here's what you come up with. 0.5454, etc., or repeating. This is not the same, so it would not be either. It can't be exponential growth for sure because y is decreasing. It's actually neither because you're not multiplying by the same number each time.